Hello, I hope this video finds you well, and thank you so much for listening to this video and tuning in. Yes, today we are looking at a line function. In most cases, we know a function is drawn on the Cartesian plane y and x-axis. Let's say we have a line that's like this. It's a straight line. It cuts it here, it goes down here, then we're going to have the x-intercept. We know what is an x-intercept. Already what we know with x-intercept is that its y is going to be 0, because you see y along this line is 0. Here's the origin, right? Let's say here it cuts at 0 and 4. It's a point here, 0 and 4, and then we have another point here where x is 2, and then your y on the other side, let's just say it becomes 8. Then this point is going to be 2 and 8. And we all know the basic of the definition of the Cartesian plane, that y on this side it's positive, that's why we have 8. This side is negative. If we had a number here, it's going to be negative. X, this side is positive and that side is negative. We don't, just for clarity's sake. Then this is a line. What they're calling us to do is to get the equation of this line, because it's not given as an equation. But we know the standard form of a line, it's y is equals to mx plus c, where m is the gradient and c is the y-intercept. This is the y-intercept, the y value of the y-intercept, the y value of the y-intercept. So we can directly say our c it's 4. It's 4 because the y value of the y-intercept is 4. But I'll just show you how to calculate it so that it doesn't confuses you with time. Then now let's find m first. If we're calculating m, we say m is equals to, we know the distance, the gradient equation, whereby it says y2 minus y1 over x2 minus x2, right? Yes, so it's given in the formula sheet. You don't worry much about it, but with time you're just gonna know it by head, right? So we take 2 points along the line, therefore we can name this point 1 and then name this point 2. Therefore let's substitute with that. Y of point 2, here it's point 2, therefore y of point 2 is 8 minus y of point 1, which is 4. Just get it there. And then x of x2 of point 2, it's 2 minus x of point 1, which is 0 there. Then our gradient simplifies to be 8 minus 4. These are like terms we add, we subtract in this case. Therefore we have 4 over 2 minus 0 is 2. Then we ended up with 2. So our m is 2. We're just going to take m and substitute here. The very same way we've been doing with a, b, c, and d for cubic, and a, b, and c for parabola. Yes, and then we have our m. Now we are looking for c. Then we substitute m into the standard version of it, whereby we get our m is equals to 2 times x plus c. Now the only thing that's left is to get the c. I've explained to you that c is just the y-intercept, right? Where it cuts, meaning our c is 4. But we can calculate it by doing what? By substituting one of the points. Let's substitute to point 1, coordinate 1. If we substitute coordinate 1, then we know here it is coordinate 1, it's 4, this manner, and then the y of coordinate of point 1 is 4, and then x of it is 0. Then this gives us a c. This becomes 0, therefore 4 is equals to c. Or we can just say c is equals to 4. Or we can substitute. Let's now substitute point 2 if someone decides to choose point 2, right? If we substitute point 2 here, we just say y into is equals to 2x plus c. Point 2 tells us that y is 8, and then 2 is what? And then x is 2 plus c. Then the only unknown is c. Here we have 8 minus 2 times 2 is 4. As it crosses, it changes to minus 4, and then that gives us C. As well, this tells us that C is equal to 4. Or you can just say our C is our y value of the y-intercept, which is 4. Then in total, we end up with the equation of this line being y is equals to 2x, where 2 is our gradient calculated here, plus 4, which is our C. Got it? Yeah, so we've dealt with gradient now. I've explained a bit on the line. Now we can move forward and understand. Let's say now the scenario. Let me bring a point of intersection before I go into midpoint and the distance formula. Right? Let's say now you have another function. This is function 1, another function 2, whereby it's y is equals to negative 2x plus 4. Is it plus 4? Minus 4. Let's just say plus 4. C. Yeah, so you have a two function. Remember, let's comment on m. If m is positive, it simply means your graph is increasing, it's going up. You see it's going up. And then if m is negative, simply means your graph is decreasing, it's going down. Therefore, this is a decreasing function, this is an increasing function. Right? Sure. So now there might come a point whereby they want you to calculate the point of intersection. Point of intersection, that's where this graph meets another graph. So this graph, the decreasing one, meets the increasing one. Where they meet, this point is called point of intersection. Therefore, how do we get it? That's where this graph is equals to this graph. Then we simply just say, gonna say 2x plus 4. This graph is gonna be equals to this graph. That's where we get the point of intersection of these two graphs. And then by so doing, then you see we're only left with x, and then we're going to get the x coordinate of this point, whereby it's simply going to be 2x, this one goes to the other side, and then it becomes plus 2x. We already have 4 this side, and then this 4 crossing to the other side becomes plus. No, it's plus, then it becomes minus 4. Then this side we have 0. This side, how do we have? We have 4x. 4x, we divide by 4, we divide by 4. Any number divide 0 divided by any number is just 0. So we know for these two graphs or functions, they cut at each other at 0, at x is equals to 0. But we don't know why. Then we need to get the y value. Since we know x, we can substitute the x in this or in this, one of the two functions, to get their y, the original functions. If you substitute in the first one, you see we just put 0 in there, we get what? This becomes 0, we get 4, right? Or if we put in this, y is equals to minus 2 into 0 plus 4, because we know x is 0. Then this one as well, this becomes 0, it becomes 4. So actually, these two graphs, they meet at x is 0 and y is 4. And this point, we call it point of intersection. That's where they intersect, point of intersection. Same applies. It can be a point of intersection between a line, let's say 1x plus 4, and maybe a parabola, maybe x squared plus 5x plus 4. Then if you want to find the point of intersection between these two, all you do is that if you want to find the point of intersection between these two, all you do, you just equate them. You're just gonna say 2x plus 4 is equals to x squared plus 5x plus 4. Then you solve for x. Once you get x like 0 is equal to 4, you substitute in any of either this one or this one, then you get your y value. That's it. As simple as that. So yes, as we move right along, it gets us to explain the midpoint. Midpoint is the middle point between 2 points. Let's say you have a line. On a line, you have a point here using 0 and 4. Still remember 0 and 4 on the straight line. And here we had 2 and 8 on this line. The midpoint will tell us where the middle part, this portion will be equal to this portion, the middle point. That's the midpoint. And its formula is given as x of 0.2 plus x of 0.1 all divided by 2 into y of x2 plus y of x1 divided by 2. You see this comma here in the middle, it shows that this is going to be the x coordinate, this is going to be the y coordinate of the midpoint. So in this case, remember we chose this to be 0.2 in the previous activity, this to be 0.1. Then as we get the midpoint denoted by m, capital letter M, the gradient is a small letter m, the gradient, this is a small letter m, this is a capital letter M for midpoint. Then it's going to just be x2, x 4.2 is 2 plus x 4.1 it's 0, all divided by 2 of the formula, and then this side is going to be divided by 2, and then y2 here it's 8 plus y1 here it's 4. Then this gives us what? Gives us 2 over 2 into 12 and over 2. Then we ended up with 1 and 6 as the midpoint. Therefore, this point here, the coordinates of it is 1 and 6, the middle point. Right? Yeah, that's about it. When they say calculate the midpoint between 2 points, that's what you do. And then when they say calculate the distance between 2 points, we're just going to use the very same 2 points. The distance has a formula as well. It's the square root of x2 minus this x1 all squared plus into y2 minus y1 all squared, all of it, and then afterwards we take the square root. Remember, a distance is a number. It has to just give us 1. Midpoint is a coordinate, that's why it gives us x and y. So with the distance, we're just going to substitute same way using the very same. X of 0.2 is 2 here. Then we open brackets, you're going to have 2 minus, this is the formula, it's forever be given to you. X of 0.1 is 0. Remember, you know where I get these numbers, I get them from our points. The one, you just choose which one is 1, which one is 2. It will be wise for you to reverse and mark this 1 and mark this 2 and do the very same activity all over by yourself to check your understanding. I can assure you the answers will be the same. And then y of 0.2, it's 8 minus y of 0.1, which is 4. Why are we minusing? Because we are finding the difference between the 2 points, the distance between 2 points. Yes. And then we're just going to go with the square root. In this, 2 minus 0 is 2. 2 squared is just going to be 4 plus this side 4 minus 8 minus 4 is just going to be 4. 4 squared is 16. Then we end up with the square root of 20 because 4 and 16 are like terms. And then you just go to your calculator, says the square root of 20, then it becomes 2 square root of 5. Unless if they tell you to put it to 2 decimal places, then you know how to do it over your calculator, which is 4.47. Yes, thank you so much for listening. I hope you go through this and understand, and thank you for your time. Enjoy your day.